So arithmetic sequences and series. And again, isn't that arithmetic? Yes, if it's a noun, but if it's an adjective, arithmetic. So arithmetic sequences and series. A sequence in which each successive term has a common difference between it and the previous term. And that common difference is usually indicated with the variable d. So this common difference is usually called d as in delta. We discussed this ever so briefly yesterday, but today this will be the focus. Now, 10.2 and 10.3 are going to describe arithmetic and geometric sequences and series respectively. The formulas for these do not overlap. Do you remember how confusing it was with ellipses and hyperbola? Because they had basically the same formulas with some of the letters switched around. It'll be similar here. So the difference between arithmetic sequences and series formulas will be subtle, so it'd be easy to mix them up. Be careful to use the right one for the right problem. So we're specifically talking about arithmetic sequences and series. Okay, so some of those formulas. First of all, for the nth term, if I want to find the 30th term, then I'll plug in 30 for n here. This is the nth term formula. A sub 1 is your first term. D is your common difference. N is the number of the term in question. So the nth term formula. Muy importante. So if we have an arithmetic sequence, we want to know the nth term, we'll use this formula. Now you'll notice on the sum of terms up to n, so that's the series. So the formula for the series, there are actually two of them. They are these two. S sub n is the series of all the values up to and including the nth term. So those are your two formulas. And you can, algebraically manipulate those and write those a bunch of different ways. So if you look it up on Google, you're going to see maybe a different algebraic representation of the same expression. This is how they're written in your textbook, so that's why I chose to write them this way. This top one, the consequence of the little kids' work in an elementary school classroom. Talked about this with fifth grade yesterday, but not with you guys. You ever encountered such an incredible act of genius you're just blown away by it? Somebody that maybe impressed you so greatly with some mental calculation they did or something like that. Anyway, Carl Gauss did that to his elementary school teacher in the early 1800s. So the teacher had the kids all had chalk slates. You've seen these in like Little House on the Prairie and stuff. So the kids are tasked with adding up all the numbers 1 to 100. And 1 plus 2 plus 3 plus 4, so on, all the way up to 100. And the kids, the teacher, I imagine, propped his feet up, got out his newspaper, and expected a long, relaxing wait while the kids performed this calculation. Well, much to his surprise, in just a few seconds, little Carl Gauss walked up with his little chalk slate and had the right answer on there. It's been just seconds. So the teacher said, how in the world did you get it that fast? And Carl Gauss said, well, I thought about it like this. You know, if you had the real number line as a list, 1 to 100, I could fold it in half and then add those two halves together. So 1 plus 100, what is that? And then 2 plus 99, what's that? 3 plus 98. See how they're all 101s and there's 50 of them? So 50 times 101, 5,050. Mentally in seconds. And this formula is a consequence of that. So 1 plus 100 times 50. Do you see how that would be what would happen if you plug that into that top formula? So he mentally developed that groundbreaking series calculation formula as, well, the age account varies. Some people say 6, some people say 8. I'm not sure. Just a little kid in any case. Went on to become what we call the Prince of Mathematicians, Carl Gauss. Okay, so let's find the next 4 terms and the common difference. You're going to have a lot of homework problems like this, so make sure you are squared away on this. These are all arithmetic. In other words, you don't have to worry about me trying to trick you with some other type of sequence. All the ones in this section will be arithmetic. So what is 12 minus 17? Not quite.
12 minus 17.
So negative 5 is our D, as in delta. So if I take the difference between any term and the term that came before, the result is our D. So we now know the common difference, D. And writing the next 4 terms is fairly trivial after D's been discovered. So that's 2, negative 3, negative 8, negative 13. Just take away 5 each time. This one could be tricky, you know, going from positives to negatives. That could mess you up if you allowed it to. But you got $2 and you spend 5, how much are you in debt? Well, $3. Okay, any questions about that one? Or thoughts or comments? Make sure you challenge me if you don't understand something. This is your class, you know. I'm just here teaching. I understand these not in question. You're the one I want to teach this to. All right, here's one for you. Same process. Figure it out for me. Interesting how similar your handwriting is.
Yes.
It's a fascinating correlation between these. And your work showing has other similarities. So let's see. Okay. Easy to do. Transcription errors are the worst because well, there's no way to guard against them other than just meticulously double checking every single thing you do, which is beyond tedious. But you know, on a test, it's worth it. I think I told you guys my strategy in college. I would take a test, and I was always an early finisher because I'm a nerd, you know, I studied and stuff. So I would finish with maybe half the time left, and I would just kind of daydream for 5 or 10 minutes until I was somewhat divorced from the material. You know, like when you write it, it's yours, you own it. You can't look at it objectively yet. So if you take 5 minutes and just kind of think about other things and daydream or whatever, and then come back to it and pretend like you're a teacher grading it. You go through, you'll be amazed at the mistakes you find. Like a lot of times on my first run through, I would make like an 80, you know. Then after I go through and recheck it, now it's a 95 or 100. That one strategy is probably the difference between 4.0 in college and 3.5. All right, so tell me what D is in delta is, Riley. Excellent. And then what are these next four terms, Colby?
73, 16, negative 14,
Negative
88.
Would it
says,
be 90?
Yeah.
I think there's a boo-boo in there somewhere. It's okay. Calculation errors are easy to make. Let's try it again. Macy, what do you think is on?
73, 16, negative 41, negative
88.
Oh, okay, I got you. So just one digit off. Okay, any questions about this? Super simple. You will get an ACT question along these lines. There's always a sequence and series question or 2 or 3 on the ACT because it's just low-hanging fruit. You have to think about ACT test question creators. They're humans, and most of them are math teachers. So they're going to gravitate towards the subject matter that's easiest to make a test question out of. And I call that low-hanging mathematical fruit. And these are just so easy to make a multiple choice question out of. You can put a really good distractor answer in there. It just would meet all the ACT question criteria pretty handily. So expect to see something along these lines on your ACT. And there's usually 1 or 2 on the statewide dual credit as well. Okay, explicit and recursive formulas. So given a sequence, can we write an explicit and a recursive formula? Well, first of all, an explicit. So this is our a sub 1, which we'll need. And the difference between these two is 21 minus 12, which is 9. So I need a sub 1 and I need d. And then I'm going to use the nth term formula. So a sub n equals a sub 1 plus n minus 1 times d. So a sub n equals 12 plus n minus 1 times 9. If I plug those values in, then I just simplify. So 12 minus 9 is 3 plus 9n. So that's the explicit. In other words, the formula for this sequence. So use the nth term formula and then simplify is all we have to do there. Now for the recursive. So the recursive, I just set f sub 1 equal to whatever that first term is. And I say f sub n equals the previous term, which is f sub n minus 1 plus 9. So we're going up by 9 each time is where that comes from. It's the simplest way to do it for an arithmetic sequence. So that entire bit would be the answer, both those things. Because remember, recursive formulas, you have to fix a couple values, 1 or more values, and then the definition depends on the previous state. So if I were to tell you, I'm 13 years older than my brother, well, you still can't tell how old I am unless you all know how old he is. So that's a recursive definition. It depends on something else that you have to know. So here we say it's the one that came before plus 9. Well, you have to know the one that came before. So you need a starting point, and that is f sub 1. All right, here's one for you guys. Tell me the explicit and the recursive formula for this. It seems too simple. Right. Caitlin, tell me what you think the explicit formula was.
Not sure, but I guess it was 23 plus 11.
Okay,
I
so
wasn't sure from the first example how you got -9. So I just did -12 to 35 as well.
well, let me show you. So a sub n equals a sub 1 plus n minus 1 times d. A sub 1 is just that first term.
Mhm.
And then n minus 1, we can't do anything with quite yet because we need to distribute. So if I take 23 minus 35, you see how that's -12?
Mhm.
So that's our d, our common difference. So the simplification of that expression is what we're looking for. And all we do here is distribute. So that's -12n, and then negative times negative plus 12. Almost every error I saw on anybody's paper was they wrote this as a minus. So 35 plus 12 is 47 minus 12n. So that's what I'm looking for there.
Alright.
Colby, tell me what the recursive formula is.
F sub 1 equals 35, and then F sub n equals first term minus 4.
Previous.
Yeah.
Which would be the first term for the, if this were the second, but the second if it were the third, and so on. Good job. Other questions, thoughts, or comments? Okay, cool. Example 3, nth term. Find the 68th term. You know, inevitably, when I give this question on a test, back in the old days when I had handwritten tests and kids would have to show their work, some kid would go through and write each term all the way up to 68 because they didn't want to be bothered with the nth term formula. And I always thought, man, what an inefficient approach. Much easier to just use the formula. But we need a couple things for the formula. We need a sub 1, which is just that first term. And then we need d, which is any term minus the term that comes before. So 17 minus 25 is negative 8. So once I have a sub 1 and d, I can know any term by saying a sub n equals a sub 1 plus n minus 1 times d. So if I want the 68th term, and actually I started doing something crazy on my test, I would do like the 150th term just to prevent that brute force method from being practical. Okay, so a sub 1 is 25, and then n is 68, like so. Okay, so that's 25 plus 67 times 8. Well, 60 times 8 is 480. 7 times 8 is 56. So 5, 3, 6. Is that right? Somebody with a calculator? 67 times 8. Is that 5, 3, 6?
5, 4, 3.
Is it, Mason? So you're saying it's
67. Yeah.
so negative 5, 3, 6. And so I get negative 5, 1, 1 when I add those two together. So that would be the 68th term of this sequence. Questions, anybody? All right. Here's one for you. Tell me the 68th term. The thing about these is that it's easy to know if you got it right or not. Okay. Mackenzie, tell me what the 68th term is here.
1,780.
So we usually write it like this, whatever the letter we use to represent the sequence, and then a subscript of the term number. Okay, any questions about that one? All right. So arithmetic means, these are a little different. So, and this for the first time, maybe it's something you haven't seen in a previous study of sequences and series. So a couple different ways to find these. I want to make sure I'm...
12.8.
Yes. So the first value is 4.3. The last one is 12.8. Okay. So the way we're going to find this is, first of all, we're going to find the D value that would make this an arithmetic sequence. So you want numbers to fill in these blanks, and they don't have to be 4. There could be 6. There could be 8. It'll say, find so many arithmetic means between this value and that value. So the question here is to find 4 arithmetic means between 4.3 and 12.8. But again, it doesn't have to be 4. It can be greater. Way better than that. Okay, so this will be a sub 1. And then a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. So we're going to use those 2 values to find out what D would have to be. So if I say a sub n equals a sub 1 plus n minus 1 times D, and then a sub 6 would be a sub 1. Well, we'll go ahead and plug it in here. 4.3 plus 6 minus 1 times D. And I also know A.6, A sub 6 is 12.8. And see how that'll be pretty easy to solve algebraically. So I'll subtract 4.3. So I get 8.5 equals 5D divided away the 5. So 5 goes into 8.5. Let's see. So that'd be 1.7. So if we just add 1.7 each time, we'll find these intervening values. So 4.3 plus 1.7 is 6. And then 7.7. And then 9.4, I believe. And then 11.1. And we found all those using our D value equals 1.7. So that's the method of finding arithmetic means. In your text, there's also something called second differences, which I intentionally skipped because I've never seen it on an ACT or the statewide dual credit test. So we'll ignore the next example. But first, one for you guys.
why it wasn't adding up in my head.
The way you wrote it, that was right. Oh, 16. You're welcome. It's okay, man. Arithmetic is frequently not the strong suit of accomplishment addition. It's just not the way the brain works.
The harder the math, the easier it is for me. The easier it is, I struggle.
I've had a similar thing. Okay, so Clay, tell me what the second value here would be.
6.4.
Good. What's the next one, Kobe?
8.9.
And the next, Mackenzie? Excellent. What's the last one, Ron? Excellent. So any questions about arithmetic means? Anybody? It's 2.4, and to calculate D value, you needed this. So that's where that comes from. Any other questions? Good question. So I skip example 5 again because second differences, nobody ever encountered that on an ACT or SDC, so we forego it. Summing of a series. So if I want to sum up the sequences in an arithmetic sequence, it's going to look like this. But you see how these intervening values complicate our life? We can't just plug it in the formula as is. Well, we can plug it into one of the formulas. We've got a sub 1 and a sub n. But I don't know what n is. If you look back at those formulas, there are two in the blue down here. So this one, I would need to know what that n value is. For this one, I would need to know what that n value is and what the d value is. So that's a little bit of extra work to use the second one in this case. We'll just stick with the first one. N over 2 times a sub 1 plus a sub n. So times a sub 1 plus a sub n. So that'll be the sum that we're looking for, but we need to know the n value here. So I know a sub 1 is 5, or negative 5 rather, and then I know the d value is 2 minus a negative 5, or 7. So a sub 1 is negative 5, d is 7. So let's figure out what the n value is here. So a sub n equals 317, and a sub n equals a sub 1 plus n minus 1 times d. So I can set these two values equal. 317 equals negative 5 plus n minus 1 times 7. 317 equals negative 5 plus 7n minus 7. 317 equals negative 12 plus 7n. Add 12 to each side. 329 equals 7n. Divide away 7. And if you get a non-integer here, you've screwed up because, of course, we're only going to have integer values. So if you run into something that doesn't divide evenly, you should investigate. 47. So n equals 47, meaning that last term is our 47th term. Once we get to here, we can go back to our sum formula, because all we needed was the n to plug into it. So S sub 47 is 47 over 2 times -5 plus 317. This doesn't have to be an integer. So -5 plus 317 is 312. 47 over 2 times 312. 7332. That is the series. The sum of all those values would be that. And of course, that dot, dot, dot stands in for the other 40 whatever values that are between there. Questions about this? All right. One for you. Tell me what the sum is. Okay. plus 18. Oh, yeah, that's right. This would be plus a sub n, which is this. A sub, the very last term. And so what is the new? Where's that? Okay. First of all, let's figure out what n is. So what's n in this case, Macy?
38.
Good. And so we want to know the sum of the first 38 terms. And what is that, Ron? Very good. Yes. Can confirm that. Okay, any questions about this? Couple little errors in writing down the formulas and stuff. Be careful with those. The only remedy for that's practice. You know, you're gonna put a plus sign where a minus sign should be or whatever until you work out about 5 or 10 of these. Okay, and in the spirit of facilitating that practice, here's you a brief assignment.